right, so we're doing 1 through 7 from the Unit 1 test retake. All right, so a lot of people did much better on, so this, all this like writing stuff was 5 points, and then the graph was 4 points. Did you guys get that? Okay, a lot of you guys did better on this, but you messed up on the graph. Okay, so let's just go through. First of all, you have to make sure you read everything carefully. It says, state the equation of the parent graph. What is the parent graph here? Cubic. Does everybody see how we can figure out that it's cubic? Yeah. Okay, because of this cube here. I mean, this is just a shift. That's a shift. That's a stretch. So if you take all of that away, what's left? X cubed, right? So the parent graph is y equals x cubed. In other words, it's a cubic function. Okay, that was the first point. And then sketch we'll do later. Describe the transformation completely. Okay. Okay, yumsicles. Okay, so right here, right here, right here, and right here. But you know what I realized? I think that you guys aren't that clear on the proper order. So what's the order? When you're doing transformations, you do it in the same way as PEMDAS, okay? According to PEMDAS, you do the parentheses first. So you're going to do this first. So what's this? So that's a horizontal shift, right? Sometimes. Horizontal shift, 1 unit to the right. Now remember, if it's minus, it actually goes to the right, and if it's plus, it goes to the left. Horizontal shifts are like counterintuitive, the opposite of what you would think. After that, according to PEMDAS, what do? The multiply. You see that? How that happens first before that? So this is multiplying by -2. So technically there's 2 things happening because it's 2 and it's a negative. That one, the order doesn't matter. You can, then what does a negative do? Flip. How? Vertically or horizontally? Vertically. And then, okay, so the order here doesn't matter. Okay, and then what? What does a 2 do? Stretch how though? Vertical. Vertical stretch. How do I say it? By a factor of 2. And then lastly, okay, this is confusing. Lastly, what does this do? Okay, so what kind of shift is it? Vertical shift, right? 4 units. It's minus, so it actually goes down. Okay, so those were your 5 points. All right? I usually put a check mark next to it if you got it. Now, I do want you guys to notice that even though number 2 is first a horizontal shift, and then the third and fourth step is the -2, as Raquel was saying, the order here doesn't really matter. You know why? Because this affects it horizontally. This affects it vertically, right? So technically they're unrelated. So whether I go horizontal first and then vertical, or vertical first and then horizontal, that doesn't really matter. But what does matter is you better do that last. Because this one, let's see if this yellow shows on top of a yellow paper. Okay. Because this one is vertical, so but this is also vertical. This is a stretch and this is a shift. So it matters. Do we want to do the stretch first and then the shift, or the shift first and then the stretch? Stretch first and then the shift. Giselle and I talked about yesterday, a lot of people find that it's actually easier, even though between these two, technically the pink should go first and then the blue, right? But since they're unrelated and it doesn't really matter who goes first, we realize that it's actually easier to stretch first and then shift. Okay? Does that make sense? That's going to help us for the graphing. Yes? Oh, no, I think you had a question. Okay. So, now, can I just take a moment to recognize that we had all sorts of funny looking things on our test that were not cubic in nature at all. Can you see yours? Okay? So we had some animals. Okay, in 5th period I had this like monster looking thing. See, that's not cubic, right? We know that I cannot. Okay, that's 2, right? Because this is not cubic, right? Cubic has to go like this or like this, never like this. Okay? So, alright. So let's start with, I'm going to start in pencil with the parent function, okay? Now that we did that whole test, which by the way you guys did much better on the parent graphs yesterday. I commend you for that. Okay, so you guys help me out. Ooh. Help me out. How do I do a parent cubic? Where should I put the point? 0, 0. Where else? Okay, by the way, you always have to make sure your axis is labeled and it's the tick marks. You at least have to do a few. You know why? Because I don't know if it's worth 1 or 2, if I'm going by 1 or 2. And the x and the y's can be scaled differently. So you have to at least give me at least 1. You know what I'm saying? Okay. Huh? Okay. So 1, 1. What else? Okay. So then should I go ahead and make a line now? No, because you know it's not supposed to be straight. It's cubic, right? So what else? What other points do I need?
2 and 8.
2, why 8? Because 2 cubed, 2 times 2 times 2 is 8. Well, 1, 2, 3, 4, 5, 6, 7, 8. Oh, I could do that. Why not? Okay. Oh, I put it on the 3. Thank you. Yeah, it's okay. You make mistakes, but you have to catch them. Okay, and then from -2, I go down 1, 2, 3, 4, 5, 6, 7, 8. And then, should I start connecting it like in a weird curly sideways thing? No. Should I go woo, 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 and before I make my way there like pinball? No. Okay, oops. All right. And then I put arrows. That's my parent graph. But what happens to this parent graph? It shifts, stretches, and shifts again, and flips. But let's do this one first, okay? If I were to flip it, this thing all of a sudden goes this way, right? It goes from here to here, right? Can we stretch and flip at the same time? Yeah, we can do that. We can do that. That's all right. Okay. So you take the x stays the same, but take every y value and multiply it by what? -2. Okay? So what's the y value right here? 0. What's 0 times -2? Still 0, so it's going to stay here. Okay? What's the y value here? 1. What's 1 times -2? -2. So it goes down here. Whoa, it flipped. Okay? What is this y value? 8. What do you, if you multiply that by -2, it's, oh, it's going to be way, so basically way down there. You know it's going to be way down, way low, okay? Okay, so we'll just kind of leave that down here. Ooh, okay. All right. And then what about this one? What's the y value here? -1, but now it's going to be, -1 times -2 is +2. And then this one down here was -8, but if you multiply by -2, it's going to be +16, way up here. So basically, even though I don't know exactly what's going on here, I know that it has to go way steep. Okay? But it shouldn't go beyond the 2. You know why? Because at 2, it has to be super high. So if I'm going past it, I have to stay here. Do you see what I'm saying? Does that make sense? Okay. So there is this nice, so what did I do so far? Basically, this purple one is y equals -2x cubed. Is it not? But what do I have to do with it? Shift it over what? 1 to the right, and then 4 down. So let's use a different marker for that, or thing for that. I only have 3 points to work with, so I'm just going to use each of the 3 points. I'll start with the center, because that's easiest. I'm going to take the center and go 1 to the right, and 1, 2, 3, 4 down. Okay? Take this little guy and move 1 to the right. Now notice I'm moving the purple line, the graph, not the pencil one. You see that? Because I've already stretched it. Take this guy, go 1 to the right, 1, 2, 3, 1, 2, 3, 4 down. And you see how these are 2 dots away? These it should be the same distance because the stretch doesn't change. Okay? Take this guy and go 1 to the right, 1, 2, 3, 4 down. You see how this size is the same as this size? It's just translated, it's just shifted over. Okay? And so it should have the same shape, just translated. Okay? That was a little tricky for that little box, I have to say. Okay? So can you guys kind of tell me what was difficult about this graph? Not knowing the order?
Yeah,
Fitting it into the box, definitely.
Yeah, I got all the words right.
What was, did you guys all know how to do the parent graph to begin with? Did you know to start with the parent graph?
Yeah.
Did you know what to do next?
Yeah.
What do we do next? Stretching it is easiest. And then, but do you guys get now how to stretch it?
Yeah.
Okay. Should we practice one now or at the end? At the end. Okay, we'll practice on the whiteboards at the end. Okay. All right, cool. Any questions on number 1 before we continue? So pretty much, if it was like at least the right shape, I think I gave you guys a 2.
You gave me a 1.
It wasn't the right shape? Depend on my mood at the moment. No, that was too fat though.
It was steep.
No, yours was like woo, like that. I remember.
You said the shape.
I remember. True. That. Okay. But okay. Yeah. Anyway. All right. So number 2. Okay. Now, what was difficult about number 2? That letter A was easy for most people. It was B where people made lots of crazy red flag errors. Okay, when you write this, first of all, I wasn't that picky because I didn't, I was trying to give you guys as much points as possible, but you really need to have the right notation. Okay, so f of g of x equals, how many of you guys had that equal sign right there? Good, Raquel? Okay, all right, next. I'm going to do one thing at a time. I'm going to keep the f there, but this time I'm just going to replace the g. Who's the g? Square root of 2x minus 3. So I'm going to put that here. Oops. Okay, now what do I do with the g? I plug it into who? To the f. But what does f ask me to do? 2 times the argument squared plus 1. But now who is in the argument? Square root of, good, g, square root of 2x minus 3. Okay. Now some of you guys got confused here, but according to PEMDAS, we want to do the parentheses first. But look, what do you notice right away?
Cancel out the square root.
Okay. First of all, can you start adding 3 here? No. Or subtracting 3? No. You guys understand that this is an implied parentheses, right? Okay. So something, who shall be remain nameless, is being square rooted and then squared. Square rooted and then squared. Why does it cancel out? Those are inverse. Those are inverse operations. Take 100. If you square root it, what do you get? 10. And then you square 10, what do you get? 100. Back to where you started. So if you square root it and then square it, what happens? They undo each other. So what are you left with? Just the 2x minus 3. Basically, the square root and the square root and the square undo each other. Cancel each other out.
Miss, but isn't it for the thing I got confused with because the scribble was putting on the board?
Okay. Now we're going to distribute, and so we have 4x minus 3. 4x minus 6 plus 1, which is 4x minus 5. Notice my beautiful train tracks right here. Okay? So what is this? This is, you guys listen, this is a long sentence that is saying this equals this equals this equals this equals this equals this. Therefore, this equals that. Modus ponens, or is it syllogism? Okay? All right. Now here's the killer. Okay, did you guys put an equal sign? Now g of who? Of f. But we got to plug it into g. But what is g? The square root of 2 times something minus 3. What is that something? 2x squared plus 1. So most of you guys were successfully able to do this. 4x squared plus 2 minus 3. And that was 4x squared minus 1. And then if you had stopped there, you would have gotten it correct. But a lot of people thought that you can do this.
Hey, can you what the heck?
And then so that's 4. You guys laugh now, but you be surprised. And they said square root of 4x squared is 2x and square root of 1 is 1. And so they said square root of 4x squared minus 1 is 2x minus 1.
Miss, can you cancel the square and the root?
That is the biggest red flag ever. Please don't copy this down. This is the wrongest thing ever. This thing in pencil, okay?
You want us to write?
No, no, no. That is like a red flag. No, no, no.
Then what the?
I wrote it so you could recognize how wrong it is. Okay? You gotta face your mistakes. Okay. Another thing people did that was wrong was they said, oh, 4x minus 1 must be 2x minus 1 squared. Is that true?
No.
Okay, the fundamental problem is that people, when you guys see this, despite all good intentions, you are still thinking, even yesterday some of you guys did this, and this was specifically on an RMP. You had to explain why. Is this correct or wrong? Why is it wrong?
Because the couch blocks.
Huh?
Because of the couch blocks. The plus doesn't let us distribute the what?
The couch blocks?
Yeah, that's how Miss Williams taught me.
Okay, okay, okay. Okay. Okay, how come she was the only one in that class? Like, weren't you guys all in the same Algebra 2 class? Okay.
I just remember the word.
Okay, but can you guys all face this and just tell me that you understand that? Okay, all right. When you're not sure of something, what you always should do is what? Try it with numbers. Because x and y are just, at the end of the day, just regular numbers. Right? So let's try it. 3 plus 2 squared. We want to know, does that equal 3 squared plus 2 squared? Well, what's 3 plus 2? 5. Does that equal 9 plus 4? 5 squared is 25. Does that equal 9 plus 4? Heck no. Right?
We could write HN.
No. Okay. So obviously this is not true, right? So you cannot just distribute like that. When can you distribute the exponent like that? When it's multiplied. Then you can say that. Okay, but we really need to take a break and talk about why. Because otherwise, I will tell you this, and then next year you'll do the same thing, and they'll say, "Didn't your teacher teach you that?" Doesn't? You're like, "I don't remember." Okay, so, okay, what's the difference? This is important, you guys. Really important. Fundamentally, I do not agree with memorizing rules. You have to understand the why. You guys know that, right? So let's not talk about rule distributing. What does this mean? At the end of the day, this means something is being squared, right? So it's x plus 2 that's being multiplied by itself, right? And how do you do that? Double distribute. So it's going to be x squared plus xy plus xy plus y squared. So that's going to be x squared plus 2xy plus y squared. Clearly, you can see that it's not simply x squared and y squared. There's a whole couch block, apparently. Okay? There's a 2xy there. You see that? What about this, though? How come it works there? Because what does this fundamentally mean? Something is being squared. So, it's xy times xy.
Is it also missed because when multiplying it doesn't really matter?
But that's a rule. Why does it not matter? That's what I'm trying to show you right now. Okay? When you're multiplying, do I need to distribute something here? Here, why did I have to distribute? Because of the couch block. Because they were being added, right? But here, okay, I don't know. So here, this is nothing being distributed, right? It's just x times y times y, right? Which in the end is x squared, y squared. So do you see why when you're multiplying, when you square it, it's just x squared, y squared? But when you're adding them and squaring them, then you have to have a 2xy there, so you can't just distribute. Do you guys see that? Okay. But that's what people were thinking. They're like, well, this must have been 2x minus 1 squared, and then the square root cancels itself out, and so the answer is 2x minus 1. Once again, that is wrong. What should you do here? But you're like, wait, I don't know what to do. Then don't do anything, because that's the right answer. Remember, math is about logic. If you cannot logically justify doing anything else, don't do it. Don't think, oh wait, that's too easy to be true. I have to do some stuff, random stuff that doesn't make sense in the hopes that I land on something good. No, that's not what math is about. Okay? Math is about logical steps. Is it true that this equals this? Is it true that this equals this? Is it true that this equals this? Can you think of anything else this equals? Then don't say it. Don't go there. Okay? All right. You good? Okay. Hey you guys, check in. Your faces are looking a little. Is this too much?
No.
Should we take a break?
No.
Not enough, huh?
You got some snacks? Break.
Okay. Okay. I think we should plow through and take a break after we finish this one, okay? All right. But you guys look alive, okay? I feed off of you, so if you're looking dead, I'm gonna feel dead. Okay. All right. So find the inverse. You guys are experts at this now. What do I do to find the inverse? Switch the x and the y. What is this really? That's a y. So if I switch the x and the y, I get x equals the square root of 2y minus 1. People did all sorts of crazy stuff.
Show me.
Okay. Tell me what we should do. I want to get y by itself. Why? Okay. You guys, I'm going to talk about this more in depth today, but can you guys listen? If you want to get y by itself, you have to think what happens to the y and do it all backwards. Okay? So according to PEMDAS, okay, what should you do first to the y? No. What do you first do to the y here? There's no, well, I guess there are parentheses, but if I say y equals 5, what do you do with the 5? Multiply by 2, right? Wouldn't you? If I plugged in 5 here, what would you do first? Multiply by 2. And then what would you do with the number? It's 1, right? And then what would you do with that number? Square root it. That's what you would do, right? 3 steps. So the inverse, you're gonna go 3, 2, 1. You're gonna, what's the reverse? So it has to go reverse. What's the reverse of square rooting? What's the reverse of subtracting by 1? What's the reverse of multiplying by 2? Okay? So what should we do first? Square both sides. Okay? Parentheses helps. Okay? X squared equals, now we talked about this. What's the square of something square rooted? It undoes each other. Okay? Now what should I do? Add 1. Okay? So that cancels. 2y equals x squared plus 1. Now what's the next? Divide by 2. So now y is by itself. Can I do anything? Can I start canceling out this 2 and that 2? Can I do 1 and this? Can I? No, just. If you can't think of anything that makes complete logical sense, don't do it. Okay?
X plus 1 over 2 squared.
Oh, yes. Thank you for reminding me. Thank you. Because that's what I saw so many times. People said x plus 1 over 2 squared. Pero por qué? That is my question. Is it because you first... Okay. Oh, whoa.
I see it, miss. I sees it.
Okay. Lo que
The
pasó.
square root thing was done to the whole thing. And then I guess they assumed to do the square to the whole thing.
No. Exactly. You know what they did?
No, I did it right.
Let it be known that this is wrong. Okay? What people did was they said, oh, right?
I see that.
And then they said, loop, 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 loop. Loop, 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 loop.
I did that.
Okay, right?
Oh, I can see that.
Okay, but what was the biggest illegal move here?
The Addy won.
Yes! Can you just do that? No! Okay, this guy comes with the whole family. You want us? You want me? You gotta take all of us, right? You can't just take that -1 and add 1 to him, take him off to the side. You before you get there, you gotta square root it and multiply it by 2. There's a lot of layers there, and you just bypassed all those layers and went straight for the kill. You can't do that.
What if you're
Okay?
What if you're a goat?
You see how that's a big? You guys see how you can't do that? That's a red flag right there, you guys. That's a red flag. That's disrespecting the parentheses. Okay? And you know, when you guys ever see the square root, you should always assume there's a parentheses there. Okay? Okay, so do you guys see how this helps to kind of write out the order and then do it backwards? Okay. All right.
Oh.
What? No, but if you guys took more time, you just take more time because you don't know what you're doing. Okay, now look. Okay, let us take a 1-minute break because this is a little bit daunting. Yes. Take a 1-minute
nice
stretch
work.
break.
Extra.
An extra present.
I got 1 point.
I remember Miss Cornell used to do that. If you used to use her vocab words, she'd give you extra.
You need to go to your house for this.
Miss Cornell? Yeah.
Oh yeah.
We would get the.
They just agreed with me. Well, what are you doing right there?
The class point?
Was that not supposed to be going down?
Oh, is that Williams? Isn't that Williams?
Yeah, Williams used to do that too. Yeah, she started doing it. But remember when she started doing the word of the day thing? You can use the word of the day in the sentence.
Remember when Amber used to use like 5 and 1?
She's like, fight like a sentence.
I was like, damn, boy.
Jones or my sister?
No, she used to use like 5 words in 1 sentence. I was like, huh. She'll make a paragraph, dude.
Let's start cooking, Joe. We'll melt those things and use that. Just like get random supplies and provide. Rachel.
Do pop up?
I feel like she's still recording.
There's not a recording.
I bet that you can hear her. Oh, Jordan. No, she paused it. Pause it.
No, she didn't.
There's a pause button right there. That's fine. If there's a pause button, that means it's like...
Let's talk about someone that hears this after
Okay, guys. Okay.
I feel like that was
Alright, you guys, these were most difficult. Very, very few of these got this right. So let's talk about this. Very, very few people got this one right. Okay, sketch the graph. So here's the graph. This is a non-parent function, so that's what makes it a little hard. Okay? But whatever point we see, we just have to, you know, technically you could have chosen points and plugged them in, right? Okay, so what is this point right here? This is, oh, let's start with this one. Let's start with this one. 1, 1, yeah? So which value do I use, the x or the y? I use the x. Okay? Take my 1, and I'm going to do You know what? No. That's too hard.
Just do it. Just do
No.
it.
Don't do that. Don't do that. No, don't do that. Okay. What is this? What is this transformation? Okay, but what's the order, guys?
Parentheses multiply.
Okay, well technically though, what's the order? Parentheses. So what is this? So 1 to the right, and then flip and stretch, right? The order here doesn't matter. Stretch and flip. Okay, stretch by what? By 2. And then we move, shift 2 up. Okay? Yeah? So, I don't know about you guys, but this part kind of stands out to me. Doesn't it stand out to you? Oh, okay. I don't know why, but that part stands out to me because it's just like, it's easy. I can put a handle on it. Okay? So what I would do is actually graph my transformation step by step on here. So do one at a time. There's 3 of them. So the first one we could do here, and even maybe the second one we could do here, and then we'll move it over to the 3rd step here. Okay? So first, all I have to do is move it 1 to the right. That's easy, isn't it? So this point moves over here, like this point moves over here, this point moves over here, this point moves over here. This one moves over here, huh? So that's true. That's true. Yeah, it makes more sense with parent graphs.
Like get it like done.
Okay, you know what? Okay, I like that.
So give us those 2 points back.
Okay, no, you didn't lose a point for that.
Extra credit.
What are you talking about? Okay. You know, in my my 5th period, every time they do something semi not even good, but just anything like reading or something, they go, oh, coin, and they're like really big. They're really excited about their coins. See?
What are you doing?
But it's
Wait,
kind of a
you're
joke
doing
because
coins?
they know that they're like, now they're the only ones with coins, and they're like,
I want a coin too.
Okay, they're like really into
What
the
color are we,
coins.
miss?
We are orange.
Okay.
You don't do the point?
No, that was last year. That's so last year. Okay. All right. So she wants to stretch. Do you want to stretch and then flip, or flip and then stretch, or do it at the same time?
Or at the same time.
Let's do it at the same time. Okay.
Gucci Mane time.
All right. So if I were to stretch this, I think stretching is easier. How do I stretch something? Find the y value and multiply it by the factor, right? So what's the y value here? 1, right? If I multiply 1 by 2, what do you get? 2. But now it has to flip, so it's going to be? -2. Okay, what's the y value here? The same, right? 1. So if you multiply by 2, you get 2. And then if you flip it, you get -2. So this guy stretched and flipped. Okay, it stretched for a hot minute, but it flipped. Okay? All right. Which point stands out to you next? This dip thing? Yeah. Okay, what's the y value here? -1. If you stretch that, what does it become? -2. But if you flip it, it's going to be +2. Okay, so again, it's stretched for a hot minute and then it flipped. But it's got to connect. See that? See that?
Yeah.
And then, which one is nice to pick from here in this section?
The one and the one.
How about this one? Isn't that nice? What's the y value here?
What about where the arrow went?
0. What's 0 times 2? 0. And then if you flip it, it's still 0.
Ooh.
But you know it's a straight line, so you know you could just keep going on the same slope. Down 2 over 1. Okay? So you see how we just stretched and flipped that V? Now we just need to stretch and flip this little piece. Okay? So you pick one point on that piece. Which one is a nice point? Well, this one's not nice. That one's not nice. Okay, this one. Okay? What's the y value here? -2. If I stretch it, it becomes -4, right? And you flip that, it becomes +4. There you go. It is stretched and flipped, my friends. Okay? Now what should I do? Move it 1 to the right. And then we have to move it 2 up. Can I do that in one step? Okay. So take this point. It was negative, what is this? 1, 2, 3, 4. Negative 4, 0. Right? 1, 2, 3. You know what? I'm just going to I'm not going to trace it, but I'm just going to like put the points here. Just so I don't get confused. Okay, so you see how that's what our graph is? Matter of fact, I could do it in pencil. Okay, you see that's what we just did. But now what do we have to do with it? Move it 1 to the right and 2 up, up. Okay, so take this one, move it 1 to the right and 2 up. Uh-oh, it's in the same spot as the other one. Does that matter? No. Take this one and move it 1 to the right and 2. Am I doing this right? Oh yeah, okay, yeah. This one, move it 1 to the right and 2. 1 to the right and 2. 1 to the right and 2. Up. So then we have our graph. See that? It's a little tricky, but doable, you know? What's the key? First, figure out what's the transformation and what order you need to do it in. And then do it one at a time, break it down. First, we stretched and flipped it. So we only did it in 2 steps, right? First, we stretched and flipped, and then we moved right and up. If I moved it up first, though, and I tried to stretch that, it would get totally wrong. Because now, if you move it up, the y values change, and then you stretch, you multiply by -2 the new y values, you're going to get totally lost. You see? That's why that order matters. Does that make sense? Is that okay? Okay, this was in the RMP, you guys. But, you see how hard that was, kind of? That was a challenging problem, right? Kind of. But if you saw it on the RMP, and you thought, I know how to do it, blah, 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 copy the answer key, then you're missing out on like probably half an hour of like hard thinking that you should have done. And then it bites you in the butt on the test. So don't take the RMPs lightly, you see? When you see it and you know it's hard, that's when you have to tackle it, not run away from it, okay? Okay, other questions? Okay, now this is tricky too because now I transformed it for you. You tell me what transformation I did. That is hard. It makes you think backwards, okay? So, what order will we do first? Wait. Jordan. Yeah, you hold on to that. And we'll talk after class. Okay, so, okay. I was like, okay, what? Okay, anyway, okay. So, what would you have to do first? Huh?
Nothing, sir. Nothing.
You would stretch it and flip it first, right? And then what would you do? You would do horizontal and then you would do vertical, right? So first, let's think. Was there any stretch?
No.
How can you tell if there's a stretch or not? No, stretch. It should look longer, right? Like stretched out. Does it look stretched out? Look. The slope, does it change? No. Does this one look any longer or wider or like different shape? The only thing it looks like is moved around and turned around, but it doesn't look pulled apart? No. So there's none. Okay? No stretch. Is there a flip though? Why? How do you know? It's like a bowl that was like facing up and now it's facing down, right? So there is a flip. Okay? There's a flip. Okay, so if I were to flip it though, okay, what happens if I were to flip it? Let's graph what it would look like. This area, what's the y value? -1, so it would flip to +1, right? This one right here, what's this point? 3, so it's going to flip to -3. You see that? Okay, this point right here is what? The y value is -3, so it's going to flip to +3. This whole thing is flat on -3, so it will be flat on +3. And it will go like this. You see that? Do you see how this is a mirror image right here? Because it just flipped? Okay. So then that's done. I flipped it. Now what do I have to do to get, is this the same thing as this?
No.
What's the difference?
You moved it to the...
It moved one up and one to the left, huh? Right? Because look, here there's just like one space gap between the y-axis, and here there's a 2 space gap. So move one to the left, and then it moved one up. Okay, so do you guys agree that basically the only thing we did was flip, left, and up? How do I do that? First of all, you guys said x, but it's not x. What are we doing it to? We're doing it to f of x, okay? Because this is a graph of f of x. It's not a graph of x. This is a graph of f of x, right? What do you do to f of x? How do I do that? Do you need that 1 there? No, it could be invisible, as long as it's just a negative, right? How do I do the 1 to the left? I have to fit in a +1 over here, huh? So let's make it bigger. Okay, and then how do I do the 1 up? So there it is. Huh? That's not so hard? No, it's not. But it kind of is complicated because you have to be logical and not think that math is about like just random stuff happening, but like be logical and take it step by step by step. What did we do first? We asked, is there a flip? Is there a stretch? We decided there's no stretch, but there is a flip. And so we drew, because we visualized for ourselves what the flip looks like. And then we said, from that flip, is there a shift horizontally and is there a shift vertically? And then we had to go from there to actually see what it looks like. And don't forget that this is f of x, not just x. Okay? All right. Real quick, we're going to have to talk about this. Okay, perfect. Okay. It says 2 points. People did all sorts of stuff. They didn't understand the question. And that is really important. You have to read the question. Given these 2 points, and if you're not quite clear, always graph it. Only a few of you guys did that. It doesn't take long. -7, 3. 1, 2, 3, 4, 5, 6, 7. Down 3. 1, 2, 3. All right, you're just sketching it. There's P. Q is -4. 1, 2, 3, 4. +1. So somewhere around here. Okay? We have 2 points. What are they asking us to do? People just start plugging in any formula they've ever learned. No, no, no. Read the problem. Okay? Find the length of the segment. What are they asking you to do? The length of a segment, we talked about this. How long is this segment? Is the same as the distance from P to Q. And so you have to do the distance formula. So PQ is going to equal the distance between P and Q. And so you have to do x2 minus x1 squared, some people forgot the squared, plus y2 minus y1 squared. If you study, you should know that it's squared. And you should also know that because this comes from the Pythagorean theorem. A squared plus b squared equals c squared. All right. Okay, now, what are my x2s and x1s? Here's my x1, y1, x2, y2. You see how that x, y, x, y? So it's going to be -4 minus -7. That parentheses can save your life. Okay, and 1 minus -3. Okay, a lot of you guys made the mistake right there. Because look, if it's minus negative, what happens to the double negative? Positive. So it's really -4 plus 7 squared and 1 plus 3 squared. -4 plus 7 is 3. 1 plus 3 is 4. And then can you cancel? Can these square roots and these squares cancel? Red flag. No. PEMDAS, do the parentheses first. 3 squared is? 4 squared is? 9 plus 16 is? And then if you guys left it like that, I know I said simplest radical form, but that reduces. What's the square root of 25? Now, find the equation of the perpendicular bisector of PQ. Same points. What's a perpendicular bisector, Matthew? What's a perpendicular bisector?
We know that bisector
Bisector means what?
through the middle.
Through the middle of PQ. I have to go through the middle, so I have to find the middle, and then what?
And perpendicular, so it's to
90 degrees. Perpendicular means 90 degrees. They want the equation of this line. Okay? How do you find an equation of a line? In point slope form. What does point slope form look like? y2 minus, or not y2, y minus y1 equals m times x minus, and this is part of your studying. You should have memorized that. So your answer should look like this, not y equals mx plus b form. Do you guys have to study this? Point slope form is different from slope intercept form. For point slope form, what do you need? A point and a slope. Doesn't get better than that. Well, right here, can we find a point? Which point are we going to use on this black line? Remember, are we trying to find the equation of the purple line or the black line? The black line. So what point should we use? Can we use P? Oh, in color? Okay, anyway, this is the purple, okay? This is the black. Okay, fine. Give me a sec. Are we looking for the equation of the blue line or the pink line? The perpendicular bisector of PQ is the blue one. So I have to use a point on the blue one. What point could I know? The midpoint. So does it make sense to plug in the values of P or Q into your equation? No. So many people did that. You guys plugged in this point or that point. But no, we need to find the midpoint. Okay? Hold on, you guys. I know it's been a long class, but come on. We're almost done. That is the midpoint. Okay? And where to find the slope of this line, the blue line? The slope, since it's perpendicular, it has to be opposite reciprocal of the slope of the pink line. Okay? So let's find the midpoint. How do I find the midpoint between 2 points? I have to add the x's, -7 plus -4 over 2, and add the y's, right? So that's -11 over 2 and then -2 over 2. You need to stop talking, please. Okay, and then that's -5.5 and -1, yeah? You use this point, not the other point. What's the slope? Find the slope of PQ, right? Which is y2 minus y1 over x2 minus x1, which is 4 over 3. If the slope of PQ is 4/3, if this is 4/3, what's the slope of the blue one? -3/4. So I have the slope, -3/4, and I have my point. Where's my point? Is it -7/3? Is it this? What is it? That's my point, because that's the point that's on the blue line. The other ones are not. So all I have to do is plug it in. Y minus -1 equals -3/4 times x minus -5.5. And you can leave it like that. Right? So tonight, you guys, I want you to do the test corrections on, I will put the answers, okay? I will put the answers, but I won't show you the work. I will put the, wait, hold on, I dismissed you. I will put the answers on Schoology. Just do the trigonometry, 8, 9, 10, and 11, okay? 8, 9, 10, and 11. Hold on, still haven't dismissed you. If you are not passing this class, I would like you guys to stay after so I could talk to you for a minute, okay? Do you know who you are?
Yes.
Hold on. I can just tell you who's passing and you can leave.
But you already told me.